All right, so we're working on some pre-calculus today. Find the equation of a parabola whose focus is 2, 3, and whose directrix is x equals minus 5. Whenever I'm asked to find the equation of a conic with some given information, I like to go ahead and draw this information out on an xy axis as such. And mainly I do this so I can get the form of the equation that I'm going to need to use here. The other reason, yeah, this is more like secondary. It gives me some information about distances and such that I can clearly more see. And these distances that I'm speaking of, they form part of the equation. We'll get more into that in a second. So if I were to draw out some possible candidates for a parabola, your parabola can open either up, down, left, right. And if you said, well, what if it opened up? Well, it would have to look something maybe like this. You have your vertex here, and your focus would be like kind of above it. Well, no, because it crosses the directrix. You can't have your parabola crossing the directrix. Okay. How about the other direction? Kind of what if it's down? Well, it would maybe have to look something like this. Again, you're crossing. So it's going to have to be left or right here. Okay. Now, it's going to be opening them to the right, because if it was to the left, it would look something like this, and you're crossing that directrix. So no. So it's going to go to the right. But the most important part, because I know that it opens to the right, it has to look as such. It has the form of y minus k squared equals 4a times x minus h in parentheses. Right, when the parabola opens up to the left or right, it's this form right here. All right, so the h and the k here stand for the vertex, and the a here is a distance. And it's the distance from the foci to the vertex, or the vertex to the directrix. Okay. So either one of those. Now we don't have that here, but we can figure that out. The vertex will be here in the center. So sorry, I just drew it right now on this xy plane just to show, it's in the middle between the directrix and the focus. And the distance from here to here, but I'm not saying it's like negative 2, 3 here, not saying that. This distance is a here, and this distance is a as well, okay? So, but what we do know is this. Look at the total distance from the directrix to the point 2, 3. Horizontally, the point 2, 3 and the directrix x equals minus 5 is 7 units away. So if you add the two distances a and a here, that's 2a. 2a would equal 7, or a equals 7 halves. Okay, so we know what a is equal to. And the other thing we know is as follows. We can figure out the vertex. The vertex is right smack in the middle between the directrix and the focus. And the way it works is if you're starting with the focus here, you can go back 7/2 units this way. Let me do this like in red here, it's more clear. And yeah, if you were to subtract 7/2 units from that point 2, 3, and when I mean subtract 7/2 units, subtracting it from the x, you would have 2 minus 7 halves, which is negative 3 halves. Okay, so your vertex here would be negative 3 halves, comma 3. And yeah, as you can see here, the y value does not change for the vertex, and the foci stays the same. It has to be kind of like they lie on the same axis here. All right, so with that information, I can get my equation. it's going to be y minus k. In this case, k is the y-coordinate of the vertex, that's 3 squared, equals 4 times a, and my a is 7/2. And then my x value for my vertex is minus 3/2. So we put that in there, and yeah, I apologize, it's a little small, but just, there it is. And we get y minus 3/2 equals 14, x plus 3/2. Yeah, so simplifying that, 4 times the 7/2, and that is the equation. And this works pretty well in the same format that I got here in terms of like distances and such, as I said, in finding an equation for virtually any conic that you're asked for. Okay. All right. Well, thank you for your time.